Welcome back to the stream. A little later than before, but I didn't forget. Looks like we are live on all the usual spots over on Diode Zone, on YouTube, on Twitch. Alright. Welcome back, everyone. So my current task right now is getting this old machine fixed up to the point where I can use it for some comedy, but also get it off my desk. It's a bit of a sprawl at the moment. Yeah, these are all the guts to an obsolete voting machine that runs on a 486 embedded PC that we've been kind of poking at a bunch on these streams. It turns out there were a host of problems with this thing in just trying to get it to run arbitrary software. Some of these were configuration weirdnesses, like a whole bunch of trouble just related to having kind of a very obsolete hard disk addressing mode that the BIOS and the software and the compact flash card all have to agree on. And that's been kind of a pain, more than expected. And then some unhelpful EEPROM settings in the touchscreen controller that we had to overwrite using a tool that we found on the website for the manufacturer, which was only slightly broken. So the touchscreen controller is now something that it's a known quantity. We understand what the protocol is supposed to be. We can talk to it. We've got drivers for DOS, Windows 3.1, and Windows 95. I think there are even Linux drivers for this touchscreen. It's the 3M, what is it called? The DynaPro, DynaTouch. I think DynaTouch is the actual film that they make. So this is basically 3M makes some fancy plastic film, and then they also market some controller chips to make their plastic film more appealing to people. So that's what we've got here. It's a rebranded microchip pick with a 3M sticker on it that says DynaPro. So I think DynaPro is the name of their touchscreen product line. And I think specifically the controller we have is termed the SC3 for Serial Controller 3. And there's a closer view of the motherboard. That one BGA package, really the newest looking thing on the board is the processor, because it pretty much is the newest piece of technology on the board. The processor is fairly integrated, but then they added a bunch of just random PC peripherals to it. There's a Super I/O chip, which has a hard disk, floppy disk, parallel, and serial controller, dual serial. There's an external video chip here and the video RAM that goes with it. A whole bunch of glue logic to support peripherals that operate on 3.3 volts and 5 volts. So I don't know how custom these slots are. They look like they should be PC card slots, but I haven't actually verified how they're wired or what voltage they're at or anything like that. There's the flash card it boots off of, which is configured as an IDE device, a hard disk, there's a power supply. And it's kind of obscured here because it's behind that connector. The touch controller is a little IC on that board that's sort of under the connector that goes off to the actual LCD. I still don't know why they put the touchscreen controller on the main board instead of putting it on the board that's actually attached to the LCD. Yeah. So that rainbow colored ribbon cable goes off to the LCD. The chip with the two tiny wires hot glued to it is the touchscreen controller. So the touchscreen controller chip's way over there. It's got an 8-pin header, that disconnected one. Goes all the way over here to this giant oversized breakout board, which is mostly empty space, but it has this really tightly packed LVDS receiver here in the corner, which is kind of behind this cabling. So the rainbow cable goes into a LVDS receiver. But there's so much empty space, they definitely could have put the touchscreen controller on this board if they wanted to. It seems like that would have been less potential for electrical interference. Anyway, there's this stuff over here. As far as I can tell, this circuitry is not related to the touchscreen. It doesn't seem to be connected. It's labeled, the labels are transistors, capacitors, resistors. I'm assuming if they were like transient suppression devices for the touchscreen, I would have seen continuity to the touchscreen and they would have been labeled like U or D or something instead of Q. So that seems like a straight through connection. Then we've got the problem. The touchscreen itself actually seems to be the cause of the intermittent faults that we were getting both in DOS on the last stream and on the original firmware. So the way this is wired, it's an 8-wire touchscreen. The actual touchscreen here is resistive. It's 2 flexible plastic sheets with electrodes on 2 sides each. So each sheet has 2 electrodes, but then each of those electrodes are set up with dual wire measurement. So you're using a separate wire to drive voltage into the panel there versus to read back the analog voltage levels. So it's like a 4-wire measurement on a resistance meter. So that's how you get 8 wires total. So using that newfound knowledge from reading the instructions that came with the OEM and development kit for all of this, the touchscreen controller chip, we found out that there should be pretty low resistance between these pairs of contacts. So like this is about 20 ohms, and this is about 20 ohms, and this is about 20 ohms, but this one has been a whole heck of a lot of trouble. I don't actually know which of these 2 pins is having the bulk of the problem. It seems like it's mostly this one, pin 5, but I was trying to trace down where in the cable the problem is. It seems like a little bit of the problem might even be in the touch panel itself. I'm trying to measure some of these resistances here, actually. I don't know what like the design lifetime of these touch panels was intended to be. This thing is 20 years old. So yeah, those are the 3 that seem to be working, about 20 ohms. And this one's been intermittent. We've certainly seen the touchscreen work. Because of this 8-wire construction, it should be tolerant to a pretty wide range of variation in the actual resistance, but you know, maybe not if this is going up into the hundreds of kilo ohms or mega ohms, right? So anyway, we could take a closer look at this, but I think I'm actually going to save the repair on this for a future stream. I was trying to figure out what substance to use for this. I think the actual original cable is made with some kind of silver ink. So seems like the thing to do would be to use conductive epoxy or a silver ink pen. I have some stuff like that, it turns out. It's just a little bit old. I managed to find it, but I am not sure how far outside the shelf life it is. So I'd made a little test over here. It was like a minor miracle that this stuff was even still liquid, but I mixed it up and I'm trying to see if it actually cures and if it cures into a conductive state. I've been poking at it and it's still not quite cured. The package I think said 4 hours, and I put this together earlier today and it's still a bit gummy. So that's still not reading any conductivity. That's reading like 15 mega ohms. So it's not really there yet. And then I tried this conductive ink pen, which was mostly clogged. I think I got it unclogged, but I didn't really manage to get enough out to generate lines that I've been able to measure. So yeah, I don't know if this stuff is actually good. I don't know if this is going to be enough, but I think most of the problem is actually in the joint between this connector and the cable. So I think what I'm going to do once I finish this test of the epoxy is to put some of the epoxy just over this tarnished section of the cable to protect it, but then to also run some small wires from those joints back to this connector for at least pin 5 and probably pin 6. So that's where I'm headed there. But I want to leave that alone for a minute until I know whether this epoxy is any good. I'm not really sure what my plan is if it isn't, because this stuff is expensive. I don't know if I want to buy more. I think it's gotten more expensive. Either that or maybe just, I don't know, maybe it's inflation or something. But I don't know. I found the package for this stuff and it was like 20 bucks or something at Fry's. And I was looking on eBay and finding tubes of conductive epoxy going for like 50, 80 bucks. Like, what is up with that? I keep saying I don't want this to be a purchasing exercise. I'm trying to just get this working using stuff I've got, if that's at all possible. But anyway, let's put this aside for a minute. I also have a bit of a software mystery to work out. So I wasn't extremely worried about rotating the display on this. Normally Windows and DOS want a 4x3 landscape display, whereas this thing is a 1024x768 LCD panel, but it's designed to go in this kind of upright portrait format suitcasey thing that the voting machine ships in. And the firmware, it's just rotating in one of its graphic stack layers, right? As far as I can tell, there's, zero hardware support for any kind of rotation. There's not, a way to scan out in a different orientation. There's not like, hardware accelerated rotated blitz or anything like that. So the rotation is something that's entirely like a software trick at the driver level. But it seemed like maybe they had implemented that software trick because, I was gaining some hope from this display orientation string here in the system.ini, and there's some corresponding options in the INF file for this driver where it looked like maybe different modes could define a setting that would flip it into portrait mode left or right. So that was in the INF file. It was here in the INI file. But I tried setting that, didn't seem to do anything, and so far the only other indication that anything is actually hooked up here is there are some strings related to this in the actual driver files. Alright, so this is the unpacked 16-bit Windows driver. Does every program have to have different key combinations for zooming? Right, so this has a sort of a main configuration file that looks like this. It's a lot less sophisticated than even something like Windows 95 was. They had like hard-coded video modes per instance of the driver in here. So you had to effectively switch drivers if you were going from one video mode to a different video mode and restart Windows. But you can see that all the different modes have an opportunity to list their own DPI, for example, and like cursor and display orientation. So display orientation seems to be a thing. Then we look at these actual drivers, or rather, I think the way I got this was just like strings star. Where do we find orientation? So besides that system.ini, we have these portrait driver does not support zero orientation messages. And those are actually coming from these mm55x blah.drive files. So I think this is a different instance of the driver assembled for each color depth. So it's probably like the same code base. I'm pretty sure these are all written in assembly because that was the norm for Windows 16-bit drivers. So it's probably not like a compile time option, but an assembly time option that just like sets different macros for different bit depths. So I would expect these to be pretty similar drivers. Anyway, I'm curious about the relationship between this display orientation flag and this driver and this message. So I figured maybe we can try to poke around in Ghidra for a minute and see what we find. It probably doesn't super matter which of these files we actually look at. It might be a little easier to understand the 24-bit driver because it'll be storing like red, green, and blue separately, and the pixel size being kind of unusual at 3 bytes will stick out a bit more, but I don't think it super matters what we look at. So let's maybe try that. That's a good question from chat about whether I could get some more reliability by mixing carbon into JB Weld. Yeah, that's a good question. If none of this stuff I've got is any good, I do have like some kinds of carbon. I found a little tube of graphite lubricant, which seems like a waste to use that as conductive material, but seems like it's possible. I also have a bunch of this black carbon pigment, which may or may not be conductive, but if that's conductive, I have a whole lot more of it. Also, maybe just like pencil graphite? I don't know. The actual thing I need to repair is very small. I wonder if Tuco's going to join us. I already missed Tuco. Finally using this weird spy software instead of my ancient copy of IDA. My computer. Where was that? So relatedly, I also found a copy of the Windows 16-bit driver development kit. So I hadn't actually looked at that before. I'd certainly heard some rumors about it because I used to work at a place where we had to write drivers sometimes. And I personally only really worked on the 32-bit slash 64-bit drivers, but I had a coworker who actually ended up writing the 16-bit drivers, and I shared an office with him while he was working on that. And so I ended up hearing about that, and it seemed pretty bad. Like, he was describing it like Windows or Microsoft just like gives you the source code for their graphics subsystem, and you have to kind of like hack at it until it works with your hardware. And well, I found that now, and that seems basically what it is. Like, looking at the code, they don't even include like proper like simple sample drivers for video. It's like basically all complicated, and it's all production code that they just give you and tell you to hack on. It's like, oh, here's our VGA driver, here's our Video 7 driver, good luck. Oh man, does Gidra know about this format? I think this is I think this file, it's a .drv extension, but I think technically it's a DLL, but it's in the 16-bit like DLL format, whatever that was called. So I guess that's new executable instead of portable executable. Cool. Oh. 16-bit protected mode. I think that is right. So I also made this incorrect assumption on the last stream. I was seeing these grabber binaries, and like, oh, what is that for? Is it for grabbing windows, whatever? But I think it's actually in the sense of capturing output from DOS applications. So it seems like those grabbers are code that has to be written for each CPU mode a DOS program could be running in. So there's one for like 386 protected mode, there's one for 286 or real mode, and those I think those files are actually loaded in as overlays in the binary that's responsible for running like the MS-DOS box in Windows 3.1. So when that runs the DOS box, it's using these little loadable pieces of video driver code in order to manage both like saving and restoring state to get back and forth between DOS and the Windows video driver, and it's using that to redirect output from the DOS box into a graphical window, as far as I can tell. But I've only read some of the documentation at this point. It does actually have some nice text files. It's not all just weird code, but there's a lot of weird code. Wow, do we have function names? Is this an export? That is an export. Oh gosh, we have named exports. QuickTime. Pixel. Gosh, GDI hurts. This looks like code. This looks like code. No? I think that was code. I probably should just turn on the like aggressive code finding options, because I usually just end up doing that kind of thing myself anyway. Anyway, I'm not here to disassemble this whole driver. I'm mostly just here to look for that orientation string and maybe any other hints that it might support some kind of rotation, but I'm kind of curious while we're here how... Oh, do we not have cross-ref for these yet? I was curious about these config strings, but we don't have references for these yet. You know, I never looked up how mouse trails are implemented. Does it have like a whole big buffer of saved rectangles for all the locations where cursors are drawn? Does anyone even remember mouse trails? I remember using mouse trails on an actual computer where it helped. It was like an old laptop where the LCD was slow and it was actually kind of difficult to see things that were moving. So turning on mouse trails would like leave copies of the mouse all over the screen for, I don't know, it would leave like, I want to say like 30 copies of the mouse or like a dozen copies of the mouse or something. So it wouldn't just like draw and then disappear immediately. So it gave really slow old LCDs a lot of time to react. Oh, CRT panning support. That's interesting. Looks like we haven't identified the other string yet. Bytes, yeah. I'd actually like to see the ASCII bytes. Oh. You know, I think they're doing kind of an old-fashioned thing where strings were terminated with $signs here. That's interesting. So that's where the message is. We don't have cross-references for any of this stuff, though. So many types. There's got to be like weird strings in here, right? Maybe not. There's Pascal style strings. What is a rep string? Oh man, I finally decided to give my Adobe subscription the boot and to give Windows the boot off of my main workstation. I'm still gonna have Windows on one of the machines here, but that'll free this machine up to actually be like a fast computer with Linux, so I'll be able to run stuff like what I'm doing now on a machine that has more than 4 gigs of RAM, which should be nice. But I want to switch to using Kdenlive for editing, and unfortunately the Windows port of Kdenlive is not especially usable, at least last time I tried it. So having a powerful Linux machine will actually let me use Kdenlive, I'm hoping. I'm trying not to put my arm in this epoxy here that's curing on the table. That's better. Fixed length string. I don't know if there's a good way to deal with this without writing a custom type or something. I don't know what rep string is. Let's just try it. No effect. Okay, whatever. I'll just leave the string terrible. Let's try their aggressive instruction finder. I don't really know what that'll do if I turn that off, the null termination requirement. But that seems like what I want. Looks like we found a few more things. I wonder where Tuco is. There's a question about whether I've tried DaVinci Resolve. Yeah, I did try it briefly. I could try it some more, but I think if at this point, I would rather just like jump right to something that I can hack on more if I want to. Like I've tried a bunch of different editing programs. I wasn't extremely impressed with Resolve, but like I could probably get to like it. I just didn't really see a reason to spend effort on liking a thing that was just another proprietary program that, you know, I didn't really have any special reason to like. I mean, there's a lot not to like about Premiere, but at least it's pretty powerful, and like I found some good workflows within that. Before Premiere, I was using Final Cut Pro, which it was alright. I mean, I was used to Final Cut Pro for a long time, but I had so much trouble actually getting it to deal with like large video files like I'm often trying to edit. Okay, I mean, it's possible that some of these strings are just not used, but like I know some of these strings are used and we haven't found references, so let's get the references working. I'm assuming that if I follow the initialization path, I'll see where some of this INI file kind of stuff is happening, or maybe even the exports, or imports rather. Like if there's ordinal imports. Oh, I've got a table of those, don't I? I think this would be in the SDK, not the DDK. I used to know the function for reading any files. Don't remember right now, though. Thought I'd recognize it. Oh, is that it? Get profile int? I actually don't want the Win32 version of this. Oh, does Wine have docs for this? I'm gonna have to read Wine's export table. kernel 386.exe16. Good times. Ah, this is brilliant. We've got the int21 handler. Ah, wine. What a thing. Anyway, I wanted the list of ordinals. Yeah. Get profile int, get profile string. These are how you read any files. So that's ordinals 58 and 57. So let's look for those. We have 58. No ints, just strings. I was trying to label that. Wait, was that the only reference we had? Gosh, I'm still kind of hitting IDA keys by habit. Oh, Control-Shift-F. That is a two-handed key combination. Well, good. So there's one reference here. Okay, so these are all offsets. How do I notate that? I don't actually know how to use this program. Oh, this is the other kind of reference, right? The R. Yeah, okay, so there's just two different reference dialogues for the two directions. Memory. Oh, yes. Love segment offset addressing. How are I supposed to do this with the keyword? Oh, let's... Okay, CS is 1008. Ah. Yay, strings. Intel. That's concerning. I'm guessing this is a buffer with the ini file's name in it. What is this 32-bit stuff we're doing all of a sudden? Okay, where even are we? I'm just concerned because I was expecting either we'd see a bunch of calls to get profile string and maybe some to get profile int also, or that this would be a fairly simple wrapper and then we would see a bunch of calls to the wrapper. I don't know, these aren't all parameters for get profile string, are they? Oh yeah, why does that take so many parameters? Maybe MSDN has this under get profile string 16. No, maybe wine is going to be the best documentation for 16-bit Windows. I don't know if the parameters are going to be the same here as the 32-bit version. But app name, key name, default, and an out buffer. Is that a segment? I don't actually know what the calling convention is for this. Gosh, it's like an alien landscape. I never really did much 16-bit Windows. Like I did a non-zero amount of it when it was relatively new, but I wasn't really big into it when it came out. I learned kind of the basics of C and stuff like that, mostly in DOS. I got kind of interested in Windows, but I didn't really get more interested in Windows until 32-bit. And then, like, by the time I got, like, more serious about programming, I had figured out Linux, and I was kind of more into that than any of the Windowses. Oh, they're pushed left to right. So weird. So is there an int at the very end? I guess that's the size of the buffer. Yeah, okay. Gosh, Pascal calling conventions. That's a blast from the past. Interesting. So this is not even getting driver settings. This is just getting, like I was assuming the internationalization was the setting we were getting maybe, but that's actually the app name. Okay, did we miss any other config stuff? Ordinal 58. Oh, we have get private profile. That's actually, I think, what we would be using for the drivers INI. Gosh, 16-bit Windows are so weird. So do we maybe have get private profile int? Yes. And we also get private profile string. So I'm more interested in int because that's where most of the settings would be, but I'm actually kind of curious what is string. Like there might be fewer of those, so we could just take that out. Ooh, there's a bunch of these. Why are there fewer ints? Huh. Can I relabel this? All right. String, string, int string. Cool. Word string. What is the key shortcut for any of this? Insert. Oh, where even is the insert key on this? Insert. Have I ever pressed insert? Oh, it's way over there. Okay. System.ini. Yay. File cache size. That's handy. I don't think that was documented anywhere. Display. Cool. There's a way to disable system to video blitz in the ini file. Okay, I was expecting there to be more integers. Expecting / hoping. This time it's reading the control panel ini. Oh, what is DS? Very close to CS. There's so many parameters. String, 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 pointer, word, string. Yeah, okay. Maybe the key name is stored here because it's like specific to the instance of the device that we're dealing with or something. This is the default. What is 58? Yeah, so that's where we just were doing the language lookup of some sort. Is this some kind of big initialization function? Oh yeah, this is called from entry. Now we're making BIOS calls. I could probably figure out what these are actually called if I read more driver development kit source. Ooh, we have a string. 1990. This is the length of the buffer, only 9. 1018. Gosh, I'm surprised Tuco hasn't come in. He's usually nowhere too far away. Screen size. That's juicier. Oops. I'm used to that ancient IDA having serious problems. If you define something as one type and then you want to change the type, you have to go through and manually undefine stuff. It seems like this handled that nicer. This is also just significantly less old. Are these pairs of 16-bit words we're packing in here, maybe? Anyway, this is just like a table of mode-specific functions that we're jumping to. Oh wait, this is a string. Are these just little fragments of strings? 4201, 1024, 1024. $600. $1,600. 1280. $640. Yeah, this is not a null terminator. We're just masking off 3 bytes and comparing it here. This is also fun because this is code that's designed to run on a 386 in 16-bit mode. So you have access to 32-bit registers, but the default for everything is still 16-bit. Are these Visa mode numbers? No, that's a pointer to a mode info structure. Okay. Yeah, it's funny. There's some text in this driver that's like, this driver is the general purpose, driver for any video mode, but it's just they have separate hard-coded initializers for each video mode. Okay. Part of me is tempted to just like organize these video mode initialization functions, but I don't think I actually need to. I should stay focused on the ini file. Gosh. That's better. Oh man, setting up these segments is annoying. This is an encode segment and it's data. That's a number. That's in the data segment and it's data. And the data segment's still in the same place. cursor color. Huh. This is also a string. Interesting. H cursor color 0. I can't put dashes in here, right? Oh, I can. Gidra, you're weird. Do I even want to do that? Makes me nervous. I want keyboard shortcuts for more of these things. Like changing the type of reference here. Code segment. Current selection. That is a weird thing for the driver to care about. What are we doing here? I should look back at what's actually in that file. Actually, I think that might be a mode list file. Yeah, okay, so current selection is actually a setting in here. And these aren't filled in yet, right? Get system directory. There's another one right down here. Also a current selection. Oh, that was the name of the config file. I don't really care about this enough to look at it super hard, but it looks like we might be loading a mode-specific INI file. And there's another table of mode-specific stuff. Or maybe just a table of allowed values. These are also strings. Can I do that? I just saw Alexis's comment that the $sign was the least cursed string termination. Actually, I might agree with that. I thought Pascal strings were. Okay, yeah, we were talking about two different things. Yeah, Pascal strings, which we did have an option for here, didn't use a termination character. They used a header byte that told you how long the strings were, which saved you from having to scan the string. It was actually kind of nice in a lot of ways, but it meant that either you had to commit to using a ton of memory, like more than a whole byte, to store the length, or just limiting your strings to 256 bytes, which was sometimes a problem. We hadn't really developed the motivation for variable length integers in most places. Underscore. Oh yeah, and this just jumps right into int 10. Gosh, this is also low level. Like, within one function, we're going right from like ini file string all the way to calling into BIOS. I mean, this was definitely handwritten assembly. No compiler would write code like this, at least not in 1990. Did I put that in right? Oh, DPI. Oh. I assumed that these were the names of entry points, but I'm wondering if they're also config options. Because like system to video blit turned out to be an on-off switch option. I'm wondering if there are ini file options where you can disable individual kinds of acceleration if they're causing problems. Oh, and I hadn't seen these error messages before. Are these underscore terminated strings now? Okay, we've got some nulls. Yeah, no, these have nulls. They must have a build time switch that swaps these out for more descriptive error messages. What is this? What is that? BMX. Ah, here's our error table. Standard mode requires blah blah blah. Unloading only. Oh. This is the first string in this big old blob. Standard mode requires the VGA display driver. If upgrading to a newer version of Windows, please rerun setup from disk 1 and continue past the error message, then select VGA driver. I'm assuming this is trying to be $ terminated. Yeah. Sorry, you must run this driver on chips SVGAs. Sorry, you must have chips linear frame buffer SVGAs. Sorry, Video BIOS does not support this mode. Yeah. Video BIOS does not support linear addressing. Yeah. Video buffer is not located at. This is the one I was interested in. Portrait driver does not support zero orientation. So let's come back and look closer at that in a sec. So we have these two use linear drivers. Oh. So it's doing an acceleration check, and if the acceleration check fails, it's like, we have a driver for you. It only does linear frame buffer. What is the difference between these? Oh, one of these is no acceleration, one of these is no memory mapped I/O. Warning or error BIOS cannot set this mode when simultaneous display type is selected. Change display type to previous setting, CRT, using hotkey. Hotkey. Wonder if our BIOS has support for that. Oh. Cannot load cntv bios.dll correctly. That sounds intriguing. And then press any key to continue. Yeah, so who uses this string table? I'm going to try to find some of the other conditions that might lead us here, like memory mapping failed or CNTV BIOS. Actually, that might be an easy one to look for just because that one also has a string in it. Of course, it's not like this is going to be loading it by file name. Maybe that won't actually help. Is this code? Yeah, I think this is code. That doesn't look like code. Not bad. Now we've got some low-level I/O access to the chip, which, if we cared where this was specifically, we could look up that I/O on the chip data sheet. Why is this a function? I think this is just a function with a fall through above it. More I/O in here. I guess Gidra's handling the fall through, it's just not notating it here. Does the disassembler know, or decompiler know about it, I wonder? Oh. It just decompiled the rest of this as part of this function. I guess that works. I guess code can be part of multiple functions. I mean, this seems like it would be a fairly serious error, like display the error, wait for a key press, and then crash the system kind of thing. I don't know. Oh, we're asking for a key press. We could probably find that. Yeah, this press any key to continue. Is this calling DOS to wait for keys? Probably. Gosh, it's halfway tempting to get out a physical book I have that might be easier to read for the interrupt than this RBIL. This is very thorough. It's just it has so much esoteric stuff that when I'm looking for something really basic, it can be a little much. There's a way to do this with DOS and with BIOS, and I just wanted to have both of those handy. This is going to be impossible to Google for. Whatever. Just be patient and do this. What is this? Huh. VXD services. Man, 16-bit Windows is so weird. Oh, I think that's what I wanted. N21AH1. Something like that, maybe. Where are we at here? Age 9. Ooh, 6 might be it too. Okay, so it is using DOS to write strings. Ah, this is a $sign terminated string. Yeah, it's gonna have a bunch of calls to that. Okay. and that's character input. Maybe this is our wait for any key. That's lucky. I mean, I'd expect it to be nearby to the strings because this was all written probably in a file or maybe a couple of files. So we are switching the data segment. Is this going to be like the segment we loaded at? I think the strings are in the code segment. Oh yeah, pfft, look at that. That actually kind of makes sense. What is it? 10.3. Oh. AH0. Yeah, no, that's actually just set video mode. I remember this one off the top of my head. AH0 and AL3 is just going back to text mode. I'll find it in the doc anyway, but that was, sorry, an interrupt A. There are these little codes you can use to search for these, right? Like, yeah. AH0, AL, and then the video mode table is where. Where are the notes? Oh, there's an MSR list in here. That's fun. Oh, there's table. I don't know why they didn't put the same pound sign in front of this. That would have made it more sensible to search for. But yes, here's the mode table. Mode 3 is 80 by 25 text. What is the difference between 2 and 3? I don't remember what the difference is between mode 2 and mode 3. Might just be color. Okay, so this thing that I thought was just like the thing we do on the way out of the driver, this is actually like a panic routine. So I think the first string comes from a parameter we were passed in DX. Then we go back to setup driver. What are we doing in here? Oh, maybe this isn't a panic function. So that's weird. We call setup driver, then we go down here, change video modes, and call setup driver again. DX is definitely a parameter for this though. So it starts with 0. Maybe DX is like a retry flag. So I guess that's like an error recovery path for driver initialization. Right, like a compiler would also not do this thing where we're like passing variables between functions and registers. Like I think setup driver is intentionally returning an error code in DX here. There should be a code segment relative address. Oops. Oh. Okay. Gosh. So sometimes it prints messages from data segment, sometimes from code segment. What is the data segment here? I mean, disassembler is assuming 1018. We can try that, but I don't know if this is going to be in range. Oh, cool. What is this? Oh, right, this is an empty buffer. This is what we read from... Really? This was a buffer we were using for the mode. This might be like a multi-purpose buffer. Yeah, okay, so we're making an error string up here. Multi-purpose string buffer. What is this instruction? Is this supposed to be a move from AL? Are we doing like a string substitution or copy? Oh, this is so weird. We're doing unaligned word rights on purpose here. Thanks, x86. Maybe we found Printf. I mean, I doubt this is a general purpose Printf. Okay, so the argument for the setup driver function is some kind of table index for maybe these are like potential IO addresses for the chip, and we're trying them and retrying if it doesn't work, something along those lines. It's funny that they're mostly using 32-bit here to handle strings. Is that epoxy still squishy? Sorry about the occasional Twitch spam. There's a question in chat about what I'm doing. I'm looking through a disassembly of an old Windows 16-bit video driver to try to see if I can find some functionality that I want that I think the driver might have. Specifically, I want to rotate the screen into portrait mode. And I've seen some references to that in the driver, but I haven't actually gotten it working. This epoxy is a little bit conductive now. I've got my probes maybe 2 millimeters apart, and it's jumping around a lot, but now it's in the tens of kilo ohms instead of in the tens of mega ohms. So that's cool. The thicker layer I put down is taking longer to cure. This is like really old conductive epoxy that I bought a long time ago and I found in the garage. I was afraid it was going to be completely seized up, but it still seemed mixable. But I'm giving it a test here before I use it on my nice touchscreen connector that I need to repair. So yeah, this is Ghidra, which is a reverse engineering tool. I have one of the driver files loaded. There are actually a bunch of different pieces that these 16-bit drivers come in, but I picked one that should be fairly representative. I guess more importantly, I saw a reference to screen orientation in here. I wasn't sure if it would be meaningful, but it seemed worth following up on. Oops. Like sending keystrokes to the wrong computer. Oh man, I almost wiped Windows off this machine before the stream, which would have been awkward, because it probably would have been, I probably wouldn't have actually had OBS working in time. Come on, USB. There we go. Takes a while for that to reconnect through the VM. Oh, Tuco's back. Tuco. Hey. Good boy. Yeah, talk to me. Oh, Tuco. I guess I should be looking for a reference to this error message table. Kind of lost the thread about where all the strings come from in that failure path. Oh. Ah. Ah, okay. That wasn't a driver lookup table, that was my actual string table. Oh, is that in the wrong segment? Yes. That's better. Let's call that error number. Shifted error number. Let's just call this error pointer offset. Oh, it's cold. Oh, we're copying. Oh, you know, I wonder if we have some internal way of accumulating multiple strings into a buffer, and then that's the buffer that we pass. So like maybe this is the number of bytes in that buffer so far. Or maybe this is like more specific than that, not general. There aren't any other references, right? Tuco. Okay, I mean, this might be the only use of that error message table. these are two separate error tables. Now we've got our DX. Okay, where are we? This is still in setup driver. That is a little strange. Should have called these messages, not errors, maybe. Oh, Tuco, don't be chomping. No, Tuco, that's not. Hey. Yeah. funny, press any key to continue is the first one in the actual string, but it's not the first one in the table. It's the last one in the table. Standard mode requires the VGA display driver. That's a weird message for it to default to. I should look for other places where DX is changed. Have a message. That's cool. Is this a compile time option? I wonder if it had some kind of detection routine that it's hard-coded to bypass. Is this whole thing down here just like a failure path and this is the actual initialization, maybe? Yeah, I mean, that looks a whole lot like we did some test. If the test fails, we fall through here with an error message set, but whatever we were testing is now hard-coded. So presumably this value that we're moving into AX would have been like an assembly time macro. So is this function only error related? I mean, that would explain why it's reading internationalization stuff. Like, why would the video driver otherwise care unless it's about to just do an error? Right, and then we're like copying the message string. This makes a lot more sense if this whole thing is error related. Is this just handling different special characters, maybe? Yeah, this is probably formatting into a buffer. Okay, so this thing that seemed like maybe a retry, this is a different message. What is message B? That's the press any key to continue message. Okay, so that function is just the press any key. What is that? That's the message segment, right? Yes. Yeah, so this is a like printf kind of thing. Okay, does anyone else call a format error message then? We have these two calls in the entry. What was that? Shift Control F? Yeah. What is this couple instructions for? Right, what is that? Like, whatever this is, it's popular. Are we also taking a stack argument? Let's see these stack arguments. Oh, is this maybe a return address we're chaining to? Right, if that's a near call. Oh gosh, what a thing. We're just balancing the stack like really by hand here. Okay. So we return from that, I guess, and then pop a few more registers and then return again. So that's like a wrapper. Now where's DX coming from? Okay, so we saved it around this. These make more sense. Okay. These tiny icons with the tooltips that show up mostly under the mouse are not the greatest. You split the window with the camera button, of course. Okay. Is this always going to be the second message table? Oh, do we get to see it formatting? This just says video buffer is not located at. Here's something that doesn't use the other error infrastructure for some reason. Or it doesn't use the press any key at least. MB. And /n/r. I guess this doesn't use the regular formatting because they needed to do something special to put like a memory limit here in megabytes. This is probably like formatting an integer as a string or something, like this subfunction. Okay, that accounts for the references to this format error message. Then we have several references to these wrappers. Oh, that video buffer not located at whatever makes its own call to this wait for key. Which segment was this? Code segment, right? Empty string. It's a little subjective what should even be a function here. Actually, this is the one I'm interested in. This other one, 0, 1, 2, 6. Can I set a specific value? Oops. I can binary really. No results. Oh, was I off by one? No. It's not really surprising that this message wouldn't be used. I can see a few interesting patterns though, like a bunch of these are IO port addresses for sure. A lot of these small integers might be other error message table indices. All right, B is the last one. I'm fairly convinced at this point that this driver just does not have any rotation support built into it. So, other options. The thing that I wanted to do on this computer was mostly to have it fully assembled and do some like vintage microcontroller programming on it. So the things that feel most nostalgic or most like interesting or funny or whatever would be to run this maybe on Windows 3.1 or 95. Because that would be contemporary with what I was using at the time and what a lot of folks were probably using. I think I probably would have been using Windows 95, but the 3.1 stuff looks pretty familiar too. Anyway, that would be kind of fun, but not worth like writing my own 16-bit screen rotation driver. Like that seems fairly terrible. So there's a plan B, which is to, instead of running Windows 3.1 or DOS or Windows 95 or whatever on this thing, start treating it like an embedded Linux and cross-compile a tiny Linux distro that'll just do what I want. And it could even run a full-screen wine session so that it still runs the like original retro software that I had in mind. And that would let me tweak the drivers as much as I wanted. It would let me use a modern kernel. It would let me access potentially larger storage devices because I wouldn't be relying on DOS and BIOS, beyond the boot process. Might be able to do some networking with it too more easily. So I don't know, that's an option. Trying not to let perfect be the enemy of getting this off my desk, And then separately, I've got to repair this touchscreen cable, which is why I was trying out this conductive epoxy that I found in the garage. I think that's all right, but I think I'm going to save the actual repair job for the next stream, since that will take some time, and this has already been a few hours. So this might be a good stopping point for today's little reverse engineering stream. I hope that was interesting. Windows 3.1 certainly is a strange beast. We didn't even really get into the driver development kit in here, did we? Yeah, I found this old DDK, which is quite interesting. Right, so I was curious, like, oh, what is this display grabber thing last time? And there were some text files that had good references to that. Right, there's this top-level README here in document, which talks about grabbers but doesn't even explain what they are. But here it is. DDAG31. I think this is just about the display driver architecture. This manual describes Windows device drivers, so all the types, not even just display. But this defines the different types of drivers. All the kinds of things you can attach to your computer. We have serial ports, displays, and this explains the grabber finally. So it describes it as a plugin for this WinOldApp module that runs non-Windows applications. It loads the display grabbers and calls grabber functions to carry out tasks such as capturing the contents of the screen or managing output from a non-Windows application. So I looked a little bit more closely at that, and it seems like it's relying on the driver to be able to put the graphics card into a mode where, like, a DOS application can still, like, think it's talking to VGA registers. So I don't know how much of that is in software and how much of it's in hardware. Right, network and printers are the two kinds of optional computer hardware. And there's some horrifying stuff on here, like, use the stack sparingly because device drivers use the stack of the application that initiated the call to the driver. There's no way for the driver to determine how much available space is on the stack. Like there's no privilege separation, right? It's 16-bit Windows. Modal functions in the display driver have implementations based on CPU type, hardware configuration, or Windows mode of operation. For example, the xTextOut function on a 8386 CPU may use 32-bit registers, but the same function for an 8286 uses 16-bit registers. Yeah, I mean, even to this day, graphics drivers kind of have some of this, right? Because there's often kind of a sea of different operations that software ends up expecting from the device, and then inevitably some of those map to what your hardware actually does, and some of them end up being compatibility fallbacks. I feel like at the time these graphics drivers were designed, computer programmers in general didn't have quite as much respect for how, like, that pretty much is the big problem in graphics drivers. just like the breadth of API and managing like expectations around that API. It's like later versions of the Windows DDK were very carefully specified as far as how, how a driver was actually supposed to put the pixels on the screen. And here it's more like, well, here's how our code works. Good luck. We know you'll figure something out. Gosh, it's still just bizarre to me seeing, like, I haven't really spent much time in 16-bit Windows land, so stuff like, hooking interrupt vectors to offer services to other drivers, it's very, very DOS flavored, but we're not in DOS. I mean, we are in DOS, but we're not just in DOS. Physical objects, my favorite thing. Right, physical objects are not actually physical. Some of this terminology makes sense because these APIs were designed to support pen plotters also. So a physical pen might have actually been a physical pen, but like mostly the terminology is just confusing because it just describes like a style for drawing lines. There were all these attempts at DPI also, like various bits of the display standards of these eras that tried to define the physical size of the screen. But of course there is no mechanism for actually determining that. Like people just had whatever size monitor. Like the video driver basically just has to encompass like all the complexity that the graphics subsystem has access to. Anyway. Yeah, Tuco is much better than 16-bit video drivers. Well, thanks for stopping by today. Thanks to everyone who hangs out on the streams and interacts on the internet. And thanks to everyone who donates to the Patreon and keeps these going. I will try to keep this daily schedule up. I'm trying to emphasize regularity even if not all of the streams are super long. In fact, it seems like it would be better if they weren't all super long, since there's less data to store if I don't make all the streams like 10 hours. But yeah, seems like not just like disappearing into oblivion is good for everyone. So see you all tomorrow. Happy hacking.